Welcome to this tutorial on HTTP headers. I'm Vivek and I will guiding you in today's session. So in today's session, the agenda is to discuss what exactly HTTP headers are, why they are used, and how to use them. What are the different tools that are used for debugging purposes? What are different request headers? And then finally, what are different response headers? So let's start one by one. So what are these HTTP headers? So as you might already be aware that HTTP is a request response based protocol. So in HTTP request, a client browser or an end user makes a request to the server and then server sends the response back. Now there is information exchange between client and the server. So this information might be of different encoding or different types. So there should be a way available by which a client can tell to the server that okay, the data that I'm sending you, it's of this particular type. The data I'm sending you, you can decode it. It's encoded, or maybe it's password protected. The server wants to tell client, okay, if you want to access the space, then you have to enter the user and then password. So plus suppose is in a situation where a client sends a request saying that okay, I'm sending you this data, but you know what, the data size is this much. So the web server cross check with this particular value and verifies whether the data received was matching the size or not. The headers are nothing but the metadata, that means data about data that is being sent. Now why HTTP headers are needed? So suppose here is a client on the left hand side and here is a server. They are talking to each other. Now client can be running any machine, maybe Windows, maybe he's an English speaking user. But when it goes to server is situated in a place where English is not the major language. Maybe it's in China. So server might be serving Chinese content by default. So if it starts serving this content in Chinese to the end user, that won't make much sense to this end user. So by using headers, the client tells the server, hey, look, I'm a Firefox, I'm installed on a Windows machine, I support these fonts, and when you are responding anything to me, tell me what exactly you are sending and talk to me in English. Server gets these details, understands, okay, he is a guy who is running Firefox and who's on Windows system and he only understands English. So let's, uh, even though I am a Chinese server, even though I am by default set to deliver Chinese content to this particular user, I will deliver content in English. That's the reason HTTP headers are very important. This enables the client and server to communicate to each other in a better way. Now, how these HTTP headers work? So it's plain text that are being transmitted from client to the server and then back. So it contains so I'll divide these request and response into two sections. So on the left hand side you see the request headers and the right hand side is the response header. So in request header, the very first line, it says what HTTP method being used. Now in this tutorial we are not going to talk about HTTP in detail. If you want to learn more about HTTP, I have already presented in one of the tutorial. I'll make sure that I put the link in the below the video whenever I'm posting this. So go through that video if you're not clear about HTTP. So coming back to the point, the very first line contains what HTTP method is being used. Like here, it is GET request. Now, what resource is requested for, and then what HTTP protocol is being used. So that means here it says, hey, it's a GET request for this particular object, and I will be talking in HTTP 1.1 protocol. Now after that, there is a new line character that is called carriage return line feed character. So new line, it starts with the header portion. It says this is the host name and different headers are being sent. Once the header section is finished, there is a blank line that is carriage return line feed character, and then the body starts if it's applicable. Now when it goes to the server checks for the incoming request and the corresponding response is sent back. So it also tells, okay, I am also communicating in HTTP 1.1 protocol. The response code is 200. This is this stands for success, and this is human readable interpretation of this response code. So it tells, okay, this we are talking in HTTP 1.1, and your request was successful, and the content type I'm sending is text slash HTML type, and different headers are being sent in the response. And when the header section ends, at the end of it, there is a blank line which segregates the header section and the body section. Then the body starts if it's applicable. So this is how the headers are sent from in the request or in response. Now we'll see them in detail in the coming slides. So to see these headers, you can use various tools. There are browser-based plugins available like live HTTP headers or HTTP Fox that is available for Firefox. You can also use the browser-based developer tools that are inbuilt in the browser. After this tutorial, I'm going to show you hands-on how to open these tools and view these details. You can also try to use some proxy tools like Fiddler, Charles, Burp Suite, or Wireshark. They all does the same thing. They capture the packet and they show you the it should, and then you will be able to see the content. It shows the content in various formats, in plain text or the way you want to. So I'll be using Fiddler after this tutorial. So let's go to the next slide. So don't panic. There are a lot of requests being discussed here. You should know what these different request headers are, then only you will be able to understand them better. So to start with, the request headers can be categorized into different sections. We are not going to talk about these. We are just going to talk about the different headers that are commonly used. So this is not the complete list, but what I have selected here are the most commonly used HTTP headers which you will encounter in day-to-day life. The very first header is accept header. So it tells what content time that acceptable for the response. So when the browser sends a request, it tells, okay, I accept text slash plain file, or I accept image slash JPG file. Then the server will know, okay, this browser only understands this. We will send this particular response to him. Next header is Accept-Charset. That means what are the different character sets that are acceptable. One of the example would be Accept-Charset colon UTF-8. So the headers are typically name value pair which is segregated by a colon in between. So if you are viewing the header, it will be like accept-charset, then colon, then UTF-8. Now next is Accept-Encoding header. This tells the list of acceptable encodings that are supported by the browser. Now the server can respond with unencoded message as well, but to save the bandwidth, they can be compressed and served to the end user. Now, the client will tell what all encoding I do support. Do I support gzip? Do I support deflate? So that's the client's responsibility to send this particular header to the server. Only after getting this header, the server should respond with the appropriate encoding. Next is accept language. So accept language is a header which tells that what all different list of languages or human languages that a server should respond with. Something like accept language colon en-us, US based English. Now next is authorization header. So authorization is nothing but the credentials for when the server asks for HTTP based authentication. So sometimes there is a pop-up window which prompts you to enter your username and password. When you enter your username and password, it converts it to authorization header and colon, then it will contain basic, and then there is a hash. That hash is nothing but just the base 64. encoding format of username and password. Next is cache control header. So cache control header is very useful in today's scenario where different CDNs are being used. It tells the proxy or CDNs whether to cache the content or not. It's a directive or the way of telling them whether they should cache this content or not. Now, interesting fact here is that the cache control header is a request header as well as response header. Since the request response both flows through the intermediate proxies and CDN servers, both way they should be able to tell whether to bypass the cache or whether to serve from the cache. Now next header is connection header. Now connection header is also a request header or a response header. It's a way of telling the partner that whether to continue with this particular TCP connection or to close it. Client will tell the server that okay, connection keep alive. That means whenever the transaction is finished, don't terminate the connection. Use the same TCP connection for further communication. The interesting thing here is that from HTTP 1.1 onwards, the persistent connection is by default. So even if you're not sending the connection keep alive header, it will continue to keep the TCP connection open for a fixed amount of time that is defined by connection timeout. Next header is cookie. Cookies are nothing just a flat files which stores the session information. If you want to read more about cookies, there is an entire big wiki page or there are different articles in the internet where you can learn more about cookies. There are different types of cookies like persistent, non-persistent. So we are not going to the details into that. Just know that cookies are the flat file which stores the session information. When you enter a username and password on a website, server sets a cookie in the browser using a header called set cookie that we are going to cover in the next slide. Now when the next time client request for the object from the server, it sends a cookie with what the server sends previously. It tells the server, okay, this is what you sent, validate me using this string. Don't prompt me for username and password every time. Server gets this cookie value, validates it, and serves the content back if it's applicable. Next is content length. Content length is a header which tells the server that the content that is being sent, what is the length of that content. It is in bytes. Next header is content type header. So it tells the MIME type of the body of the request. Maybe if you're sending a post request or put request, you need to tell the server what is the MIME type of the object that I'm sending. Next is date header. So date is nothing, just it tells the current it tells the current date and time that the message was originated. Basically it tells date colon then what day it is, what's the day, like 15th November 2005, then the time, and then what time zone it is. It's very important to mention time zone here like GMT. Next is host header. Now the major difference between HTTP 1.1 and HTTP 1.0 is introduction of host header. This made possible to host multiple websites on a single IP address or a single server. Host header is also mandatory in HTTP 1.1. It's the name of the domain of the server or the virtual hosting to which the client is communicated to. If there are multiple sites hosted on the same server, this is a way of telling to the server from client that okay, even though your IP address 1234 and you host multiple websites, I need that to see the content of maybe www.vivek.com. The server receives this header, maps this request to the configured document root. Maybe in Apache, if it is, it will map to suppose slash var slash www slash html slash Vivek. If it's requested for another website, www.anurag.com, it will be mapped to a different document root. So that's how the server deals with multiple host names, and thus host is very important request header. So now we are going to talk about list of 4 headers that are very useful in caching. If modified since header tells the server that okay, I have this object with me, serve me the object if it's modified since this particular time. Server gets this request, it checks the last modified value of that object. When was the last time it was modified on the server? If it matches, it serves a 304 response code. That means not modified. It says, dude, you have the object, even I have the same object. You don't need to download this object again. Use the same one. What if the object time differs? Like if modified since a particular date and time. Server checks, it finds that the time of the last modified of that object is different. Then it serves the object and it also serves a 200 response code. The difference between these two are, in one scenario where the object is same, 304 response code is served. When in a scenario where the object is different, 200 is the response code is served and the object along with that. So in 304, the servers and the client save the bandwidth. Next is the if unmodified since. Similarly, like if modified, same value goes for the if unmodified since header. It also allows 300 not modified to be returned in the content. Right? It only sends a response if the entity has not been modified since a specified time in the header. If modified since and if unmodified since works only when the server has last modified value associated with the object. Another way of validating the object is through e-tag, that is called entity tag, that we're going to discuss in the next slide, that is part of response code. For entity tag, there are two headers, if match and if none match. While sending, if the object is cached in the browser, it checks that okay, if match this particular value, server gets a request, it matches the value with the e tag that the object possesses, and on the server side, if the match is correct, it serves 304. If not, the new object is served and with a 200 response code. Pragma tells the implementation specific field that may have various effect anywhere along the request response chain. So it might contain some typical values. Based on that, something gets triggered on the server side, and in response you get some additional feeds which you won't see typically when Pragma values are not present. So this is typically being used by proxies, by CDNs to debug for debugging purposes. You can also say Pragma no cache. That is one of the response header. That means it tells proxy don't cache this object. Now range header. From HTTP 1.1 onwards, the servers started supporting byte range requests. That means for each and every request, it was possible not to request for an entire object but a part of object, partial object. That's how you move the seek bar, and without even downloading the entire video, you just move to that particular section and you start seeing the video from that particular point. That's how the download managers works. It breaks the file into maybe 8 different parts and start downloading in 8 parallel persistent connections. So that happens with the range request. It tells, okay, I don't want the entire object. Serve me the object from byte maybe 1 MB to 2 MB. So only this particular range is being served in the response. Next header is user agent. User agent is very important request header. This is the header which identifies the client. It tells the server what client software is being used, like what browser is being used. Is it Firefox, Chrome, Safari, Internet Explorer? It also tells like what version of Firefox or Chrome or Internet Explorer is being used, and most importantly, what operating system it is running on. So if there are different page formation taking place on the server side based on different user agent, this plays an important role. Now next header is via header. This header tells the server that I'm coming through different proxies. The proxies typically add this header in between. Server gets this header and sees the value in it. It might contain some server name in it. Why is also important because it informs the server that I came through proxies. I'm not coming to you directly. Now the last request header we are going to talk about is X forwarded for. This is typically added by proxies in between. So RFC says that whenever the request passes through proxy servers, they have to add X forwarded for header and add the client's IP address, then whatever proxy servers it's going through, they keep on adding the IP addresses in this X-forwarded port feed. If you are trying to pass your request from a client located in India through proxy server to US, the US will get the connecting IP is of a proxy server, but it will also get the X forwarded for your actual IP address. So that's a way of telling that, okay, even though you see the request is coming through a proxy server, it's forwarded for this particular client. So I hope you are still awake and you are with me, because we have a lot to cover in the response header section, that is in the next slide. Very first response header we are talking about is access control allow origin, that is ACAO header. This is an important header because it specifies which websites can participate in cross origin resource sharing. So it's a browser security mechanism. By default you are not allowed to load content from different websites. So ACAO header tells that what all contents from which website should be accepted. It can also contain asterisk or wildcard values, something like access control allow origin : asterisk. Now accept range header. What it does, it tells that what partial content range type of the server support. What kind of range I accept. Do I accept bytes? So it will tell accept ranges : bytes. Next header is age header. So age header tells that the age of the object in the proxy server in seconds, like how long the object was cached in the intermediate proxy server in seconds. If it's 0, that means it's not cached there. If it's having a positive value, it means it's being served from the cache. Now, allow. Now it tells what are the different HTTP methods that are allowed. Maybe get, head. So it will tell, okay, allow : get, head. Other than these methods, if they are being used, the server responses for 405 response code. That means the method that you are trying is not allowed. Now next header is cache control header. So we also saw this cache control header in request headers section. So it's present in request as well as response headers. It tells all the caching mechanism from server to client, whether they may cache this object or not. You can have a value like cache control : max age equal to 3600. That means this object is safe to cache for 3600 seconds, that is 1 hour. Similarly, connection header is also part of response header. It's a way of telling to the client from the server that whether to keep this connection open or close. It can have value like connection : close. Now next header is content disposition header. So content disposition header is important because it tells the browser don't load this content but download it instead. It can also define the file name of the file getting downloaded. So it's an opportunity to raise a file download dialog box for a known MIME type on the browser, right? So next header we are going to talk about is content encoding. So remember we spoke in the previous slide where we said except encoding is sent by the browser. It tells, okay, I support a gzip encoded message or compressed message or deflate messages. This server which decides, okay, what encoding do I need to serve, and it tells, okay, I'm serving encoding message of gzip maybe, so it will serve a content encoding : gzip response header. Now coming to the content language header. So as the name suggests, it tells the client what is the language of the content is being served. Content length, it tells what's the length of the response body. In request you will see content length only during post request majorly, because it's a post body that has some length and that has to be communicated to the server. Here maybe get request or a post request response, it doesn't matter. The response will have some object. It will tell what's the size of the response. Next is content type header. Now content type header is a way of telling to the client that what is the MIME type of this particular content. Is it text/html or is it a JPEG file, images? It also tells, like in text/html, what character set is supported. So it might contain a value like content-type : text/html semicolon char set equal to UTI-8. So we keep talking about this thing called MIME type. What exactly it is? It's a media type. It's also called MIME type. So don't get confused. Its full form is multi-purpose internet mail extensions. You just understand that it's a type of media that we are talking about. Now next is state header. Similar to request header, it comes on response as well, and it tells what's the current date of the server is. Now e tag we spoke a little bit about during the if match and if none match section in the previous slide. It tells what's the value of, or the cache, whatever the value is associated with the content. It will be used for further matching with the help of if match, if none match request headers. Next is expired headers. It tells the proxy server or the browser when this response is going to expire. After that, don't use it because it's expired. Now, next header we are going to talk about is last modified header. So last modified header works similar to e tag. It tells what was the last modified time of the object on the server side. Using this value, when the request comes as if modified since or if unmodified since, the server decides whether to serve the new object or the requested object, or tells the client that okay, whatever object you have is good to go. Next is location header. So location header is typically served when there is a redirect 301 or 302 redirect being served from the server side. The location value contains where the redirect will happen. Suppose you have requested for www.vivek.com. So I'm a server, I got this request. I want to tell you that okay, the request that you have requested, the resource that you are requesting for, it's not present here, it's moved somewhere else, and the new location is this. So I'll serve a response saying that it's a redirect 301 or 302 the way I want, and I'll have a location header, and the value of this location header will the URL of the actual resource which I'm trying to communicate it to you. Now next header that we are going to talk about is retry after. A way of telling the client that if an entity is not available on my side, please don't try until the next n number of seconds. Okay. The format of this header will be retry after colon and then maybe 100. So that means retry only after 100 seconds. Now server header. Similar to like what you saw in user agent header, server header is the identity of the server. So it identifies what server is used for delivering the content. So you might think it's what could be the reason why someone want to tell what server is being used. Even I'm not very sure whether it's a good idea of serving or revealing the information to the client that okay, this is the server is being used, because if you think from the security point of view, it's better not to know what server is being used, because if you don't know what server is being used, you don't know the vulnerability. If you know what server is being used, what version number is being used, and if there are any known vulnerabilities, you'll try to, some malicious person will try to exploit it. But keeping that discussion apart, this is the server header which tells what server is being used. It can contain values like IIS, Apache, Nginx, like that. Next header is set cookie header. Set cookie header tells the client, okay, I got this session information. You should store this on your local disk, local drive in a plain text format. It can also contain the value when it's going to expire and for what part it's valid for, and what domain is it valid for. It might be restricted to only a subdomain, or it might be available for entire naked domain. Something like you want to restrict this for www.vivek.com, or you want to have it for anything.vivek.com. So the domain value may contain vivek.vivek.com or www.vivek.com. So based on the matching domain name, the subsequent request may or may not have this particular cookie present. Next header we're going to talk about is transfer encoding header. So transfer encoding header is again a very important header. The form of encoding used to safely transfer the data to the user. It may be chunked response. It might not be the complete response to the end user. So it might tell the client that okay, whatever response I'm sending, it's chunked. So the way it tells, it says transfer encoding :chunked. Next is vary header. So the definition of vary header says it's tells the downstream proxy how to match future request headers to decide whether the cached response can be used rather than requesting a fresh one from the origin server. So vary can content or vary header may contain asterisk or accept hyphen language. It's a way of telling intermediate proxy whether the object or the request is going to vary or not based on the different request languages or maybe user agent. And the next header is via header. Via header informs the client or proxies like from where I'm coming to. Similarly, like request in response also it tells the client, okay, I'm coming through this particular intermediate proxy, and the value tells what exactly it was. Something like via 1.0 Apache or via maybe Akamai CDN is serving the content, it might add its custom header. Next header is www-authenticate. This indicates authentication scheme that should be used to access the requested entity. So the value you can say, okay, www-authenticate and colon basic. This pops up a window at the end user side to enter username and password. When they enter username and password, that gets converted to a base 64 encoded value and it's being sent from the client to the server in authorization header that we spoke about in the previous slide. Remember this particular slide we spoke about authorization header. And the last header we are going to talk about is strict transport security. As the name suggests, it's a security policy header. HSTS policy informing the HTTP client how long to cache the HTTPS only policy and whether this applies to the subdomains or not. This is a new header that are being implemented everywhere. You will see if you are working very frequently with um, HTTPS configurations or websites, and if you run your test on SSL Labs, if you don't have this header present, you will never be able to get A rating. So this header helps to fulfill the security criteria to get up to A level on SSLLabs.com. There are many other dependencies, but this is one of them. If you have everything else and if you don't have this, your rating might not be A. So it was too much to digest in one session, but this is very important to understand the different request and response headers that will help you to debug when you are actually working on these. Don't sleep. We have very interesting session coming right now. We are going to learn about troubleshooting these headers on a live browser. Let's move to a browser, and I'm not going to use any plugin now. I will start the inbuilt debugging tools. I'll hit Control Shift I here, or you can go to settings, more tools, and then developer tools. It opens the same window. And here is the network tab. It will tell you the different request and response. We'll enter www.google.com. The very first request was for www.google.com. Alright. You see here the headers. The requested URL was this. Request method was get. Here is the request header. Okay. Get method path was root, HTTPS protocol. What are the different files that my browser accept here? XHTML application, XHTML, and so on and so forth. My browser also supports gzip, dflat, sts, and br. Accept languages, cookie, then user agent. So right now I'm using Chrome. The Chrome's user agent is this. Similarly, when server got the request, it started with response header. Cache control private. Okay, this is a page which should not be cached, so it says private. Content length of the page is 262. Content type is a HTML page. This is what we requested for. This HTML page was delivered. This is the date at the server. And since it's a 302 response, this is the location header which tells where should I request for the requested resource which I wanted to see. We are going to make a next request on this particular page. You see the second request is nothing but the same location value. So google.com said, okay, the resource is redirected to this location. Browser understood this response and made a new request for this particular object, for which we got 200 response. When we got this HTML page, there were multiple embedded content for which we started making subsequent requests. One thing you might have noticed that each and every these request has host header mandatory. Where exactly this host header is, we are not able to see the host header right now, right? So this particular browser is changing the host name to authority. If you try to see the same thing in intermediate proxy tools or maybe in Firefox, it will tell you what exactly the request and response headers look like. We opened the debug tool, we went to network tab. Let's open www.google.com. Okay, we requested for root, we got a 302 response. Second, we requested for this particular URL which came in the location header. Here you see it's showing the crude value whatever request we've sent. So it has host value. Host header says www.google.co.in, user agent this, accept, and so on and so forth. You might be wondering where all the different headers are which we discussed in the slides. We are not able to see them. So not every time you will see all the headers, but those headers appear whenever and wherever they are applicable. Like if the object is cached here, and if I just hit F5, see 200 response. Now in the next request, this PNG was cached at the browser level. So we sent if-modified-since request. Let's see. The last modified of the response was this. In the request we sent if-modified-since this particular value, the server got the request, it matches the value from this to this, and these two values are same. So server said, okay dude, whatever object that you have in the cache, it's good to go. So it responded with 304, that is not modified. So with all these objects which were cached in my browser are all good to go. They are yet not yet modified. Now another way of doing refresh is force refresh. We'll hit control button and then we'll press F5 in Windows. So this evicts the cached object in the browser and it ensures that every time we are making a fresh request from the browser. So we got 200 response for each of these objects. Another way of debugging is using Fiddler tool. We'll open Fiddler. Fiddler will do nothing but just intercept the traffic, and we'll try to open maybe again we'll enter www.google.com. Okay, so whatever things we saw here, similarly you will see that these things are also captured here. Google.com. Okay, we want to see the headers. These are the headers section, request headers, and these are response headers. For each and every request you can see the request and response headers. So it's pretty easy to use these tools. uh, Download it, install it, try using it, then you will feel more comfortable using these tools. I have been using the inbuilt tools of the browsers and they work great for me. In case you want, you can use custom different plugins or custom plugins or Fiddler, Charles, whatever you want to use. The concept remains the same. The headers are not going to change. The one that you are comfortable with, try using it only. It's not going to change anything what you are seeing here. So I hope you learned something new from this tutorial of mine, and do subscribe to my channel so that you don't miss any future update. Thank you so much guys for watching this. Feel free to ask me questions if you have any in the comment section.